What if I told you that 95% of everything you've been taught about the Big Bang and the early universe is basically just mathematical models and educated guesswork presented as established fact? That those confident timelines and exotic particles that scientists describe from the first moments of existence are mostly just educated guesswork? Welcome aboard Arnie's Brain Train, where we examine science honestly. I'm Alex Arnold, and I'll be your conductor on this journey, and today I'm showing you exactly how much of cosmology is built on speculation rather than observation. Now, to be fair, this is kind of how science works in general. A lot of it is guessing and extrapolation based on the best available evidence. Science is still reliable, it's just important to know what is directly observed versus what is an educated guess. The problem comes when those guesses get presented as established facts. Now, I generally trust scientists. They do excellent work with super sophisticated tools and systems. But it's crucial to understand where knowledge ends and speculation begins, because academia tends to reward confident claims over honest uncertainty. Just some quick housekeeping. I'll use whatever terms and visuals best serve educational purposes. If you're more concerned about image sources than scientific accuracy, this might not be your channel. This content was researched and written by me, and all my sources are listed in the description below. And here's the most important part. Fact check everything I tell you. Look up the studies, read the papers, verify the claims. Don't take my word for anything. Now, if you're ready to examine what we actually know versus what we're assuming about the early universe, buckle up and let's go. Let's start with something that should make you question every science documentary you've ever watched. When scientists talk about the Big Bang, they speak with this incredible confidence about events that supposedly happened 13.8 billion years ago. They'll tell you exactly what happened at 10 to the negative 36 seconds after the Big Bang, down to specific temperatures and particle interactions, as if they were there with a cosmic thermometer and a stopwatch. But here's what they don't usually mention in these glossy documentaries and textbooks. We've never observed anything like the Big Bang. We can't recreate it. We can't travel back in time to witness it. Everything, and I mean everything, about the first several 100,000 years of the universe is theoretical extrapolation based on what we see today. It's like cosmic forensics, but imagine trying to solve a murder case where the crime happened before recorded history and all of the witnesses are dead. Or you could look at it like this. Imagine trying to figure out exactly what happened in a car crash by only looking at the wreckage 3 days later. You can make educated guesses, you can use physics to work backwards, you can analyze skid marks and debris patterns, but you're still fundamentally guessing about the sequence of events. Now imagine that car crash happened 13.8 billion years ago, and the wreckage has been moving, changing, evolving, and getting contaminated by billions of years of subsequent cosmic history. According to Alan Guth, the physicist who proposed cosmic inflation theory, the entire inflationary epoch, which supposedly explains how our universe went from quantum-sized to grapefruit-sized in less than a trillionth of a second, is based on mathematical models that require at least 20 different assumptions to work. Let that sink in. 20 assumptions. That's not science in the traditional sense of observation and experimentation. That's theoretical archaeology mixed with mathematical philosophy. But of course, here's the academic gatekeeping coming in. The media, textbooks, and even many scientists present these theories as established facts. Why? Because uncertainty doesn't get funding. Admitting ignorance doesn't sell books. Saying "we're not sure" doesn't get you tenure or Nobel Prizes. The entire academic incentive structure rewards confident claims over honest uncertainty. Universities need donor money. Scientists need grant funding. Publishers need compelling narratives. So what starts as "our best current hypothesis suggests" becomes "scientists have discovered" in press releases, which becomes "it is known that" in textbooks, which becomes absolute truth in the public mind. It's not malicious, it's institutional momentum driven by human psychology and economic reality. So to be clear, while I'm not calling the entire field of cosmology a deliberate hoax, I am saying that the way that the Big Bang Theory gets presented to the public, with absolute confidence about events that are fundamentally unobservable, borders on scientific fraud. Not because scientists are bad people, but because the incentive structures are rewarding the wrong claims. Alright, now let's walk through the official timeline of the early universe, and I'll point out exactly where we shift from complete guesswork to pretty confident territory. Pay attention to how the level of certainty increases as we move forward in time from the supposed beginning. The Planck epoch, 0 to 10 to the negative 43 seconds. This is where honesty should kick in immediately, but it rarely does. We know absolutely nothing about this period. 0. Our physics break down completely. General relativity and quantum mechanics, the two pillars of modern physics that work beautifully in their respective domains, give completely contradictory answers about what's happening at these scales. Any scientist who claims to know what occurred during the Planck epoch is either lying to you, lying to themselves, or selling books about multidimensional string theory. The Planck time isn't just small, it's so small that measuring anything shorter becomes physically meaningless. It's like trying to measure distances smaller than the smallest possible ruler. At this scale, space and time themselves might not exist as we understand them. Grand Unification epoch, 10 to the negative 43 to 10 to the negative 36 seconds. Here's where things get interesting, and by interesting, I mean completely speculative. The theory says that 3 of the 4 fundamental forces were unified into one superforce at these energies. Sounds impressive, right? Except we've never observed this unified force, never recreated these conditions, and the mathematics require particles and interactions that exist only on paper and in very expensive computer simulations. Grand Unified Theory predicts the existence of magnetic monopoles, particles that shouldn't exist according to our current understanding, but must exist for this theory to work. We've never even found one, just FYI. It also predicts that protons should decay with a specific half-life. We've been looking for proton decay for decades, still nothing. But we keep the theory anyway because it makes the math work. Inflationary epoch, 10 to the negative 36 to 10 to the negative 32 seconds. This is the big one, cosmic inflation. The universe supposedly expanded faster than light, stretching from smaller than a proton to larger than a grapefruit almost instantaneously. This expansion was driven by a hypothetical field called the inflation field, mediated by hypothetical particles called inflatons, powered by hypothetical vacuum energy that we've never detected. The energy required for this expansion would be absolutely staggering, more than the total energy content of the entire observable universe today. Where did it come from? We don't know. Where did it go? We don't know. How did it stop expanding at exactly the right moment to create the universe that we observe? We don't know. We just assume that it did, because the alternative is admitting that our theory doesn't work. Electroweak epoch, 10 to the negative 32 to 10 to the negative 12 seconds. The electromagnetic and weak nuclear forces supposedly separate during this period. This is actually based on more solid ground because we partially recreated these conditions in particle accelerators. The electroweak theory predicted the existence of the W and Z bosons, and we found them exactly where the theory said they'd be. Score 1 for physics. Now, here's where I need to remind you why this matters beyond just cosmic curiosity. Understanding these early moments isn't just academic navel-gazing. These theories determine how we understand the fundamental nature of reality, the possibility of multiple universes, whether the laws of physics are truly universal, or just local rules that happen to work out in our particular cosmic neighborhood. Quark epoch, 10 to the negative 12 to 10 to the negative 6 seconds. Finally, we're getting into territory where our particle accelerators can actually recreate some of these conditions. We can make quark-gluon plasma in the Large Hadron Collider. This stuff is real. We can study it, and the theory matches observation pretty well. Hadron epoch, 10 to the negative 6 to 1 second. Quarks combine to form protons and neutrons. This is actually pretty well understood because we can observe and recreate these processes. Lepton epoch, 1 to 10 seconds. Electrons, neutrinos, and other leptons dominate the universe's mass. Most of the exotic particles from earlier epochs have decayed or annihilated. Finally, nucleosynthesis, 10 seconds to 20 minutes. Protons and neutrons combine to form the first atomic nuclei. This is one of the crown jewels of Big Bang Theory, because the predicted abundances of hydrogen, helium, and lithium match observations remarkably well. Here's where things get really uncomfortable for the standard model, and where you need to put on your critical thinking hat. The evidence we use to support these theories is incredibly indirect. It's like trying to solve a murder case where you never see the body, never visit the crime scene, and your only evidence is a witness who saw something suspicious 3 towns over 2 weeks later. And the witness might be suffering from amnesia. The cosmic microwave background radiation is our best evidence for the Big Bang, discovered accidentally by Arno Penzias and Robert Wilson in 1965 when they were trying to eliminate noise from their radio antenna. This radiation fills the entire universe and represents the afterglow of the moment when the universe first became transparent to light, about 380,000 years after the Big Bang. It's like the universe's baby picture, and it's absolutely remarkable that we can even detect it. But here's the thing that should make you pause. The CMB tells us almost nothing about those first 380,000 years that we've been discussing. Everything before the CMB, all those epochs with the exotic names and precise timings, are invisible to us. It's like trying to understand the entire history of World War II by looking at a single photograph taken on the day that the war ended. According to cosmologist Paul Steinhardt from Princeton University, the Big Bang Theory has required so many modifications and additional assumptions over the decades: dark matter, dark energy, cosmic inflation, fine-tuning parameters, that it's become essentially unfalsifiable. When a theory needs to invoke invisible, undetectable substances that make up 95% of the universe just to match observations, maybe it's time to question whether we actually understand what we think we understand. This is the essence of what I'm calling the Big Bang hoax. Not that scientists are deliberately lying, but that they're presenting speculative mathematical models as established facts, teaching them in universities as gospel truth, and marginalizing anyone who dares to question the orthodoxy. The abundance of light elements, hydrogen, helium, and lithium, matches Big Bang predictions fairly well. This is called Big Bang nucleosynthesis, and it's one of our strongest pieces of evidence. But even this evidence only tells us about conditions when the universe was between 10 seconds and 20 minutes old. Everything before that 10-second mark, pure theoretical speculation. But here's where the made-up science really kicks into high gear. Remember when I mentioned dark matter and dark energy? This supposedly makes up 95% of everything that exists, and it was literally invented to save Big Bang Theory from contradictory observations. When the theory predicted one thing, but telescopes showed another, cosmologists didn't abandon or modify their theory. Instead, they invented invisible, undetectable substances to bridge the gap. Science is essentially saying, our theory predicts X, but we observe Y, so there must be invisible, undetectable stuff making up the difference. This is like predicting it will be sunny, observing rain, and then claiming that there's invisible anti-rain that you can't detect, making it appear wet when it's actually dry. So when I say 95% of universe science is made up, I'm not being hyperbolic. Ordinary matter that we can actually observe and understand represents only 5% of what cosmologists claim exists. The other 95%, dark matter and dark energy, exists only in equations designed to save a theory that doesn't match observations. That's not science. That's elaborate mathematical fiction presented as fact. Now, before you go thinking that I'm just tearing down science for fun, let me remind you why this skeptical approach is actually crucial for scientific progress. Questioning established theories is how we make breakthroughs. Every major scientific revolution happened because someone was willing to say, wait, this doesn't add up, usually in the face of fierce opposition from the scientific establishment. Ever heard of Galileo? he was placed under house arrest for suggesting that the Earth orbits the Sun. Darwin, he was ridiculed for proposing evolution. Einstein was initially dismissed for relativity theory. Continental drift was laughed at for decades before becoming plate tectonics. The establishment has a long history of being wrong about revolutionary ideas. There are alternative theories that don't require cosmic inflation, don't need dark matter, and don't assume the universe had a beginning. The steady-state theory proposed by Fred Hoyle suggested that the universe has always existed and continuously creates new matter to maintain constant density as it expands. It did fall out of favor after the discovery of CMB, but some modern versions are making a comeback. Plasma cosmology, championed by Nobel Prize winner Hans Alfvén, suggests that electromagnetic forces, not just gravity, play a major role in cosmic structure formation. This theory can explain the formation of galaxies and large-scale structure without requiring dark matter. The electric universe theory goes even further, proposing that electric currents and magnetic fields are the primary drivers of cosmic phenomena. While mainstream science largely rejects these electromagnetic theories, it's worth noting that mainstream science also insisted for decades that space was an empty vacuum, only to discover that it's filled with quantum fields, virtual particles, and mysterious dark energy. Here's what's really interesting to me. Some of the most successful predictions in cosmology came from theories that were initially ridiculed. Einstein's cosmological constant, which he called his greatest mistake, turned out to be necessary to explain dark energy. Quantum mechanics, which Einstein rejected, became the foundation of modern physics. According to physicist Lee Smolin in his book The Trouble with Physics, string theory and modern cosmology have become so mathematical and removed from experimental verification that they're more philosophy than science. We've created elaborate mathematical structures that may have no connection to physical reality. The modified Newtonian dynamics, MOND theory, suggests that Newton's laws of gravity break down at extremely low accelerations, explaining galactic rotation curves without requiring dark matter. While MOND has problems explaining some observations, it successfully predicts many galactic phenomena that dark matter theory struggles with. The hoax isn't that the Big Bang definitely didn't happen. It's that we were told that it definitely did happen, with precise timelines and detailed mechanisms, when the honest answer is, we're making educated guesses based on limited indirect evidence and a lot of mathematical speculation. But here's why this uncertainty is actually exciting rather than depressing. It means we're living at the frontier of human knowledge. We're like explorers mapping uncharted territory, and admitting that we don't know everything is the first step toward actually understanding something. So why should you care that cosmologists are essentially making educated guesses about the early universe? Well, because this uncertainty reveals something profound about the nature of knowledge itself, and it has implications that extend far beyond astronomy. First, it shows you that authority figures, even brilliant scientists with impressive credentials and sophisticated equipment, can be wrong, can be overconfident, and can present speculation as established fact. This doesn't mean that you should reject science or embrace conspiracy theories, but it does mean that you should think critically about what you're told, especially when someone claims absolute certainty about complex topics. The scientific method is our best tool for understanding reality, but it's wielded by humans who have careers to advance, egos to protect, and bills to pay. The institution of science is not the same thing as the method of science, and sometimes institutional pressures can distort the pursuit of truth. Second, this demonstrates the incredible power and fundamental limitations of human reasoning. We can use mathematics and physics to peer 13.8 billion years into the past, construct theories about the first moments of time, and make predictions about the ultimate fate of the universe. That's absolutely remarkable, and that should fill you with awe. But we're still making assumptions, filling in gaps with our best guesses, and retrofitting theories when observations don't match predictions. The universe is under no obligation to conform to our mathematical models or our intuitive understanding of how we think that things should work. Third, Admitting this uncertainty is precisely what makes science exciting rather than dogmatic. If we knew everything, there would be nothing left to discover. The fact that 95% of the universe is mysterious, that our best theories require dozens of untested assumptions, that we can't even agree on whether time had a beginning, this means that we're living in the golden age of discovery. Think about it this way. You're alive at the exact moment in human history when we're first asking these fundamental questions seriously. Your ancestors probably couldn't even imagine the scale of the universe, and your descendants might laugh at how primitive our current understandings are. You're witnessing humanity's first attempts to understand the ultimate nature of reality. But perhaps most importantly, this should teach you intellectual humility and the value of skeptical thinking. If our best scientists, with our most sophisticated instruments and our most advanced mathematics, can only make educated guesses about the early universe, maybe you should be skeptical when anyone claims to have simple answers to complex questions about existence, consciousness, or the meaning of life. Let me address something that needs to be said directly. Modern academia has serious problems with intellectual gatekeeping that can impede scientific progress. I'm not attacking individual scientists. Most are brilliant, dedicated people genuinely trying to understand the universe. I'm criticizing the institutional structure that can discourage revolutionary thinking. Here's how the gatekeeping works. Graduate students choose dissertation topics that won't threaten their advisor's work. Postdocs work on problems that align with their supervisor's grants. Assistant professors pursue research that's likely to get funded and published. The entire system rewards conformity and incremental progress over revolutionary breakthroughs. Consider this. Albert Einstein's most revolutionary papers were published while he was working as a patent clerk, outside the academic establishment. Barbara McClintock's work on genetic transposition was ignored for decades because it didn't fit current thinking. Alfred Wegener's continental drift theory was ridiculed by geologists until plate tectonics provided a mechanism decades later. The peer review process, while generally valuable, can become a negative conservative force that filters out ideas that challenge fundamental assumptions. Grant funding creates another layer of negative conservatism. Agencies are more likely to fund research that builds on established results rather than research that might prove those results wrong. This is why you need to be educated enough to not be a blind follower, even when following very smart people. Science advances through careful accumulation of evidence and occasional revolutionary insights that overturn established thinking. Both are necessary, but institutional pressures tend to favor the former over the latter. The solution isn't to reject scientific expertise, but to maintain healthy skepticism about scientific authority. Ask questions. Look for alternative perspectives. Follow the evidence, not the consensus. Remember that scientific truth isn't determined by vote or authority. It's determined by how well theories match reality. The Big Bang Theory, despite its confident presentation in textbooks and documentaries, is built on a foundation of assumptions, extrapolations, mathematical models, and undetected substances. The first 380,000 years of cosmic history, everything we've discussed about inflation, unified forces, exotic particles, and precise timings, is theoretical speculation based on mathematical models, not direct observation. We've seen how academic incentives can discourage challenges to established theories, how uncertainty gets filtered out as information passes from researchers to the public, and how the complexity of modern physics makes it difficult for non-experts to distinguish between well-established facts and speculative theories. This doesn't make cosmology worthless, but it does make it provisional. Science works best when it admits uncertainty, when it acknowledges the difference between what we observe and what we infer, between what we can test and what we can only calculate. But here's something that might make you pause and think. At the end of the day, the Big Bang Theory is remarkably similar to a religious belief system. It asks us to believe in a scientific miracle, that something came from absolutely nothing. It requires faith that in those first moments of creation, the fundamental laws of time and space didn't exist, and then suddenly, they did. That's quite the scientific marvel, isn't it? The real lesson here is that the universe is far stranger and more complex than our current theories suggest. Dark matter and dark energy might just be placeholder names for phenomena that we don't understand yet. Cosmic inflation might be completely wrong. The Big Bang itself might be just one event in an eternal cosmic cycle that we can't perceive. But none of that's a bug in the system, it's a feature. The mystery is what drives discovery. The uncertainty is what makes exploration worthwhile. And the fact that we can even ask these questions, that we can peer back toward the very beginning of time using nothing but human ingenuity, mathematics, and cosmic light, is perhaps the most remarkable achievement of our species. Just remember this principle. Every time someone presents you with an absolute certainty about complex topics, whether it's the early universe, climate change, economic policy, human psychology, the meaning of existence, or anything else, they're probably oversimplifying, overconfident, or selling you something. The most honest answer to the biggest questions is often, we don't know yet, but here's what we're trying to figure out. This isn't wishy-washy relativism, it's intellectual honesty. And in a world full of overconfident charlatans and authoritative ignorance, intellectual honesty is a rare and valuable commodity. And that's my take on the Big Bang hoax here aboard Arnie's Brain Train, where we expose the difference between actual science and academic groupthink masquerading as established fact. If this video opened your eyes to how much of cosmology is built on speculation rather than solid evidence, hit that like button, because this kind of honest analysis gets buried by the algorithm that prefers comfortable lies to uncomfortable truths. Subscribe and ring that notification bell if you want more deep dives into topics that most channels won't touch honestly. Check out the description below and the pinned comment for all of the sources that I referenced. I want you to verify everything that I've told you. Look up the alternative theories that I mentioned and draw your own conclusions. Don't take my word for anything. Don't take anyone's word for anything. Follow the evidence and think for yourself. Drop a comment with your thoughts. Does the uncertainty in cosmology bother you, or does it excite you? Are there other established scientific theories that you think deserve this kind of scrutiny? And what questions do you have about the early universe that nobody seems to be asking? Join us next week as we board the brain train for another controversial journey. And until then, keep questioning everything, keep learning, stay curious, and remember, the world isn't always this simple, but it's always this interesting. All aboard. We'll see you guys next time. Bye.